In this lesson, we're going to continue the work that we did on the lesson 3.5, solving quadratic equations. If you're missing the lesson, make sure that you grab a copy of it before we get started. We have already gone through 4 ways of solving quadratic equations. One of them is by graphing, the other completing the square, and our final 2 were by factoring and using the quadratic formula. So we're going to skip ahead to example number 1 in the word problems. So example number 1 says, Chris and John are cutting a rectangular lawn 40 meters by 30 meters. Chris starts by mowing strips of equal width around the perimeter, while John starts cutting a rectangular patch in the middle. How wide a strip should Chris cut so that they share the work equally? So here we notice that there is no equation that's given to us. So we know we're going to have to come up with an equation. We know that the entire unit is on quadratic equation, so there's a good likelihood that we're going to come up with a quadratic equation to solve this. So the first thing to do is to draw a picture. So here I've drawn a basic sketch of what the problem has talked about. So Chris and John are mowing a rectangular lawn. So we know that the entire rectangle has to be a length of 40 and the width of 30. We also know that Chris is starting by mowing in a rectangular shape, strips of equal width around the perimeter. And we know that John is in the middle here. So this is where John is mowing, and this is where Chris is mowing. Now the question's asking how wide a strip should Chris cut so that they share the work equally? Well, what that would mean is that they would be each mowing an equal area. So what we need to make sure is that the area that Chris is mowing is the same as the area that John is mowing. The question is, we don't know how wide the strip should be. So that's going to give us an indication of what we should make our variable. We're going to make a variable for the width of the strip. So if we let x be the width of the strip that Chris is mowing, then we know the length from here to here has to be x. And because it's an equal strip all the way around, we also know that the width from here to here has to be x. And if we continue through, we know that this has to be x, as well as this has to be x. So now the problem comes back to, if we know that we've defined x as this width and x as this width here, the question is, how can we come up with an equation so that the area on the outside is equal to the area on the inside? So if we make this our a number 1 and this our a number 2, let's come up with an equation so that the area of the first shape is equal to the area of the second shape. So let's find 2 different equations for each of the areas. So we'll find the area of the first and area of the second. So obviously the area of the first is going to be more difficult because we've got a hole in the middle. The area of the second is going to be quite simple. So let's work on that one first. We know that the area of a rectangle is going to be length times width. So let's start with that. The second area is going to be the length times the width. But the length is actually a little bit more difficult to find. The length is not actually 40. This entire thing here is 40. This is 40, but minus this strip here and minus this strip here. And we know that this strip is x and this strip is x. So what's left over here is going to be the entire width, which is 40. Take away an x here and take away an x here. And what that's going to look like is going to be 40 minus x, which means minus 2x. So it's going to look like this. Our length is going to be 40 minus 2 x's. And our width is going to be similar. We know that the entire width here is 30. So if we bring it over to where we need, this isn't going to be 30, this is going to be less than 30. It's going to be 30, but minus this strip here, which is x, and minus this strip here, which is also x. So in total it's going to be 30 minus x, which is going to be 30 minus 2x. So we'll add it to our width, 30 minus 2x. And there we have our area, our second area, the area that John is going to mow. So now let's take a look at finding the area for this outer strip here that Chris is going to do. So this is like a picture frame. We would have seen this in like a grade 9 problem. So to find the area of this just strip around, we know we're going to find the area of the total, take away the area of the second, and then we'll be able to find that remaining. So we actually do already have the area of the second. We found it over here. So all we have to do is find the total area, take away the little guy here, which we found over here, and then we're going to be left with the area of the strip. So the area of the total guy we know is going to be length times width, and we know the length is 40 and the width is 30. So let's add that in. So first we're going to have the area of the total, which is going to be 30 times 40, and then we're going to subtract the area of area 2. So I'm going to subtract area 2. So we know area 1 would be 30 times 40, which is 1,200. Subtract area 2 from that. So we have 40 minus 2x times 30 minus 2x. So now we have the area that Chris is going to mow here and the area that John is going to mow, and we just have to make sure that they're equal to each other. So the last step is just to set them equal to each other. So we're going to make a new equation so that area 1 is going to equal area 2. And we're going to fill it in and simplify, and hopefully we get a quadratic. So area 1 we know is 1,200 minus 40 minus 2x, 30 minus 2x. Set it equal to area 2, which is 40 minus 2x. 30 minus 2x, and now all we have to do is simplify it. So let's simplify this quickly using FOIL. So I'm going to write it out very quickly. 1,200 minus, make sure you work inside brackets here because we are going to multiply here, but we've got a subtraction on the outside, which means we're going to be multiplying by -1. So we will have 1,200 minus in bracket 40 times 30, which is 1,200, minus 80x minus 60x plus 4x squared equals, again we're going to FOIL, 1,200 minus 80x minus 80x minus 60x plus 4x squared. Before you collect like terms, very quickly multiply this negative inside. Okay, so we will have 1,200 minus 1,200 plus 80x plus 60x minus 4x squared equals 1,200 minus 80x minus 60x plus 4x squared. I can see that these two terms are going to cross out. If I bring all of the terms onto the left hand side, I will have, or the right hand side, I'll have 0 equals. I will have 4x squared plus 4x squared. Bring the x squared terms first. Then I'll have negative 80x minus 80x minus 60x minus 60x, and then we'll have plus 1,200. Okay, collect like terms very quickly, simplify. We're going to have 4 plus 4, which is 8x squared. Then we'll have negative 280x and then plus 1,200. Hopefully I didn't make a small arithmetic mistake. So now what I have here is I have a quadratic equation that needs to be solved. The goal of this question was, if you look all the way back up to where what the question was asking, it was not asking us to find the maximum area and what width would maximize this area. It was actually just asking us, if you read it, just how wide the strip should be. So notice that this says nothing about maximum minimum. So we're not going to find the vertex here. We're literally just solving for x. So if we go back down here, we have this equation, and all we have left to do is solve for x. So we have 4 different methods that we could do so. We could graph this, we could complete the square so that there's only one x term and we can solve. We could factor. Perhaps the easiest decision here would be to use the quadratic formula, only because this might be factorable, but I'm dealing with really big numbers, so I don't want to waste time trying to factor and trying to find 2 numbers that multiply to a large number. Also, I don't want to complete the square because that's going to be time consuming in and of itself, and we were not asked to find the vertex. So I think the fastest would be to use the quadratic formula, so that's what I'm going to do. So to set the quadratic formula, I'm going to remember my a, my b, my c. So my a is going to equal 8, my b is going to equal negative 280, and my c is going to equal 1,200. I can do this because it's in standard form, starting with degree 2, degree 1, and then constant. So now I'm going to start to fill in my quadratic formula, assuming you've got the quadratic formula in front of you. Remember, x is equal to negative b, so I'm going to put a negative 280. Plus or minus square root of b squared, which is negative 280 squared, minus 4, a is 8, c is 1200, all divided by 2, and then our a is 8. So just as a reminder, as I've mentioned in class, just make sure you put this under the calculator, into the calculator first, so whatever is underneath the square root sign, and then continue on simplifying. So if we were to continue simplifying, we have x equals negative 280 is going to be positive 280, plus or minus the square root of 40,000 all over 16. And the square root of 40,000 is going to work out into a nice number. So we are going to have 280 plus or minus 200 all over 16. So now we can set up our 2 cases. We have our first x and we have our second x. So our first x is going to be 280 plus 200 divided by 16, and our second x is going to be 280 minus 200 all over 16. So if we work them both out onto our calculators, we have 2 answers. We have our first answer is x could equal 30, and our second answer is x could equal 5. So there could be 2 possible answers for this question, but let's go back to our original picture and see if these make sense. So we're going to remember our first answer was 30, our second answer was 5. So here we are back at our original picture that we drew from the situation, and we got one width. Remember, x is just the width. One width is going to be 5. That seems to make sense because we have a length here of 40, and so we're saying that Chris is going to mow a width of 5 and a width of 5 here. That makes sense. The other width we got was 30. So that means that the width here would have to be 30 and the width here would have to be 30, but that would make a width, an entire length here of 60 when we know it has to be a maximum of 40. So if there was a width of 30 here and a width of 30 here, then the length of this would have to be 60, and that doesn't make sense because it's 40. Same with this side over here. We see the entire width is 30. How could this be 30 and this be 30? It just doesn't make sense. So that means we can throw out the answer of 30, and we know that the width that they have to mow the lawn has to be just 5. And so we conclude that our final answer has to be that the width that Chris has to mow has to be 5. Now I've run out of room here, but you can write your concluding statements. Therefore, the width would be 5 meters. So next what I'd like to do is skip question number 2 and go right to question number 3, which is a little bit easier. This question says, when a ball is thrown upward, its height h in meters is given by this function, where t is the number of seconds after it's thrown. For what length of time is the ball higher than 16.2 meters? For what length of time is the ball higher than 16.2 meters? So again, this question is not asking for the maximum height, the highest height, the lowest height, etc. It's asking for the time when the height